The final device I need to control in this example is the DSP. There's a number of functions I'm looking for, and I've already created the DSP design and uploaded the descriptor file to the processor, so I should have access to all the control functions I need. I've kept this fairly simple in this example, and all the UI functions are at the bottom of the main page. All I need to control for this system is the mute and the volume. The mute button needs to toggle on and off, and I'm using the arrow-shaped buttons to the left and right of the volume indicator to increase and decrease the volume with every push. I also want to be able to push and hold these buttons to ramp the volume up and down. The final requirement is for all the button feedback, so the mute status and the volume level, to change according to the actual DSP status. What I mean by this is that if anything else mutes the DSP or changes the volume level, the touch panel needs to reflect this. So let's get started. I've got my flow tab already created, but at the moment it's empty. I'll begin by adding a UI control node for the mute button. I'll keep this simple and just look for a button push without any feedback. The feedback needs to be handled separately because it depends on the mute status rather than whether or not the button has been pushed. Now the action of the button depends on the current mute status, so that's the first thing we need this to trigger. So I need a status node to check the mute status on the DSP. When I select the DSP, I can control any of the functions that the descriptor file has provided access to, but in this case, I'm just interested in the master volume. While I'm testing the system, I'll connect to the DSP using Audio Architect so you can see the functions changing live on the BSS processor. As you can see from the DSP control, all the functions on this gain control object that I've called master volume are available to me. So all I need to do is select mute as the function that I need to monitor. When this status node is triggered, it'll return the current mute status, and I can test this using an inject node as the trigger and a debug node to monitor the output. As you can see, the two message payload strings that I need to look for are muted and unmuted. Next, I'll add a switch node with two outputs, one for when the system is muted and one for when it's unmuted. These two outputs can then trigger command nodes to either mute or unmute the system. Don't forget that when you've got two very similar nodes, rather than creating a new one, you can just copy and paste and then make a few changes. Once this is deployed, I can check the system by pushing the button on the panel and monitoring the mute function using Audio Architect. As you can see, the button works, but I don't currently have any feedback. The trigger to change the button feedback is going to need to come from an event node. The event I'm looking for in this case is the mute status changing, so I'll select the BSS processor and the function I'm looking to monitor. Now I can look for a particular state, but in this case I need to monitor any changes in the mute status. The next node I need is a switch node set up with two outputs depending on the message payload. This is identical to the switch node we're already using as the mute control node, so I'll just copy and paste this one. This time the outputs are going to change the button state rather than the mute state, so I'll need two command nodes to turn the mute button on or off. When I select the touch panel, rather than seeing the button names, I'm now seeing the button data. In this panel design, the mute button is port 1 channel 26, and I need to manually set this to true to turn the channel on. Now, if you don't already have this information to hand, you don't need to open up the panel design because it's already loaded into MUSE Automator. If I needed more information, I could open the control panel node that's in the context tab, select the mute button, and check the channel port and channel code from there. Once my mute on node is finished, I'll copy and paste this for my mute off node. Once this is deployed, I can check the system. And now I have working feedback on the button, which is based on mute status, regardless of where the mute is controlled. There's lots of different ways of doing things within MUSE Automator, and this is a good example. The switch node works fine, but I could use a change node. I already know that the button channel on the touch panel responds to true and false to turn the button on and off, so I could use a change node with two rules. When the message payload it receives is muted, I can change this to a Boolean true, and when the payload is unmuted, I'll change this to a Boolean false. Now I only need a single command node. I'll call this mute feedback. And I'll set this to send the message payload to channel 26 instead of a manual true or false. As you can see, the result is the same, but with fewer nodes. Before we leave the mute control, let's just double check what's happening using a debug node to check the mute status. Although the mute control seems to be fine, we're actually sending multiple mute commands to the BSS processor, which isn't a great situation. The reason for this is that we're changing the mute status and monitoring the mute status at the same time, which creates a very short loop. To break this loop, we need to add a short delay between the point where the mute is monitored and where it's changed. This delay node has a number of different functions. I don't need to change much in this case because I just want to delay the message before it gets passed to the next node. 10 milliseconds will probably be enough. As you can see, this time I only get a single command sent to the DSP because we've broken this loop.